or by implementing new services that complement and the products to increase customer satisfaction. So also, Industry 4.0 offers new prospects for consolidation of closed-loop product life cycle and industrial symbiosis due to the integration of value generation networks. So these are the basically the we can say that the reason that is why we are talking about the Industry 4.0. So primarily in here, if we are talking about the environmental management system, so our target is to reduce the exploitation of the natural sources and improve in the profitability. So that without exploitation of the natural sources, we can get the development. Otherwise, if we are getting the, if we are talking about the industry level and we are growing human development, but if we are exploiting our nature and justifying the different natural resources, so this is the meaningless development. So in order to sustain the human for a longer duration, definitely we need to keep the sustainable development. So if we are talking about the Industry 4.0 and we are talking the environment management, then we must need to discuss about the technology behind it. So the Industry 4.0 needs to have high environmental consequences, just like every corporate organizations and every individual. So it demonstrates Industry 4.0 technologies that have a strong potential for being beneficial to environment management 4.0. So from the next couples of slides, we will discuss about the different technologies involved in the environment management. So let's start. So first is our physical system. So one of the most significant advances in the development of information and communication technologies is represented by cyber physical systems. These are the computational collaboration systems that are in a strong connection with the surrounding physical world and its respective active processes while providing and utilizing data access services as well as data processing available on the internet. The CPS internet and relationship with the people, data and information machines and equipments in order to streamline the process of receiving and sharing data and information analysis and interpretation and decision making. So next one is the cloud manufacturing. So another possible driver of sustainable environment management 4.0 consideration is cloud manufacturing. This technology is in charge of obtaining, storing, processing, presenting, and disseminating data and information related to the manufacturing. So due to its service orientation feature, messages are issued and displayed in system to people in charge of a specific production phase for any minor changes or the need to end customer orders. So the capacity of Industry 4.0 offer customization to its client's request is very strong. So actually, these are the aspects of this. Cloud manufacturing is one of the important technology behind the Industry 4.0. Apart from this, we also need to the big data analysis. Actually, we must need to analyze the much more data which we can access from the clouding. So this is also one of the technology that we have to add to revolutionize the industry levels. So all industry data is stored and analyzed through big data analysis and grouping analysis and providing pertinent data and information on currently available resources used, machine operation, energy efficiency, waste creation, waste utilization, and pollution levels emitted are some of its possible applications for environmental management 4.0. The BDA means the big data analysis can offer historic data on a resource that might have previously been employed in the manufacture of the same commodity and could be recycled. The BD is large capacity for storing data and information, as well as its warning of opportunities and corrective needs act as indicators. Also, the augmented reality is another technical aspect to management in this environmental system of the Industry 4.0. The ability of augmented reality to advise on planning before it is implemented, simulate what will be done, and identify the need for corrections even at a distance or from different locations makes it work well with Environment Management 4.0. The AR means augmented reality works with the monitoring of production activities to, among other things, check for production line breakdowns, errors, disruptions, and failures. With AR plans may be created and viewed digitally before they are even directed, allowing any planning flaws to be corrected prior to the acquisition of resources of the unwarranted activation of other processes. So engineers, technicians, operators, and designers may verify product-wide compliances and modification needs before they are built because to the simulations that AR means augmented reality makes possible. So smart sensors are also involved in this Industry 4.0. The smart sensors are a kind of technology that alerts systems for employee viewing of potential mistakes or non-conformities, whether in materials, goods, machines, procedures, or production lines, and can qualify amount of waste or pollution produced. So the smart sensor is a key technology that can deliver these alerts to employees via systems on machines, centralized computers, or mobile devices, and can either do nothing more or act autonomously when so instructed. So location detection is another aspect where location detection make it easier to discover resources that belongs on the assembly line without wasting a lot of time or energy on operating machineries. Also, at the real-time location is very important. Location detection improves industrial agility and accurately while decreasing waste production brought on by local verification errors. And also the precision of the location is matters in Industrial 4.0. It must be neat that all the equipments are placed at the very proper locations. IoT means Internet of Things. If we are talking about the Industry 4.0, then Industrial Internet of Things is one of the key technology because it involves the data and information with key stakeholders from across the industry and beyond. The IIoT enables us to discover a variety of possibilities, including reversible or irreversible equipments and machine failures, sensors, and system issues, production disruptions, shifting consumer demand, specification, stakeholder service opportunities, and many others. So Environmental Management 4.2 benefits from the IIoT since it can avert the loss of production equipments in order to ensure that the necessary resources and modifications are handled properly to prevent waste. The IIoT also collaborates by informing customers of changing orders. Additive manufacturing, this is now we cannot say that additive manufacturing is future technology. Now mostly some of the industries are definitely trying to utilize this 3D printing technology. So the uses of resources in production is highly innovative when it comes to additive manufacturing. The AMs, the additive manufacturing's primary contribution to environmental management 4.0 is its ability to manufacture a variety of items using materials other than those found in the nature. So that's why we can utilize the materials in a better way. For some very specialized types of industries, some industrial segments can convert manufacture of their products using material that do not directly derive from nature or that are biodegradable or even reusable. The industry can use more ecologically friendly practices while acquiring materials for productions. Instead of choosing materials to be harvested or constructed, avoiding irregular ones that have a detrimental impact on the environment, additive manufacturing can make previously non-conforming or surplus materials viable to build new products that integrate them. So, apart from the technology, we need to talk about the challenges that has involved in the Industry 4.0 to environment and environment and sustainability. So, we now discuss about the challenges. So, industries committed to sustainability and the environment is directly related to Industry 4.0 technologies. In order to properly implement, operate, maintain, and dispose them, they do demand a great deal of supervision and care. So, what are the main challenges behind this Industry 4.0? The first one is cyber physical systems. So, cost for acquisition is still thought to be considerable. So, if you are talking about the challenges, then definitely the cyber physical system is the one of the key challenges, and it have the some. If we are cost also affects these things, because if we are giving at the lower level of the production level, then we must take care of the cost. So installation is appropriate locations, taking distance and space into account. So to link to every machine in production space, all systems and sensors in the manufacture areas must be connected and have real-time access to entire productive area and bypass ongoing and routine maintenances. So how these are being the challenge, and if we are trying to resolve, then definitely we have to get these facts in our mind. So cloud manufacturing, this is one of the challenges to involve in the environment management in this Industry 4.0. So we must need the sufficient data and the information storage to complete our production in Industry 4.0. And the real-time information is very much important, and be able to connect instantly to devices, systems, and computers throughout the sectors. So that's why we need the real-time information. Otherwise, the lack of if we do not have the real-time information, then it may lose the information and we cannot give the proper output. And BDA means the big data analytics. So we need the sufficient data and the information storage to further proceed our Industry 4.0. And data and the information can be received, combined, analyzed, achieved, and shared in a real-time scenario. And be able to connect the instantly to devices, systems, and computers throughout the sector. And connect in the real time to the stakeholders, changing requirements and wants. So these are the points we need to keep in our mind while we are discussing the Industry 4.0. So these are the challenges. And one of the more challenges is the augmented reality. And we must have the auxiliary devices linked with sufficient amplitude and maintain the discipline when it's absolutely essential, and connected to sensors and systems for help with production processes, and have accesses to the internet so you can use it elsewhere or in the different sectors for the industry. So these are the points we need to, these are the challenges that we have to sort out during this revolution. And smart sensors, so possessing the room and the distance needed for the proper performance, have a live internet connection, real-time system connectivity, and real-time connectivity to one another and to machine, and other machines capable of integrating performance. So definitely, if we are talking about the smart sensors, so we must need the real-time internet connection, because if we do not have the real-time internet connections, then definitely we can lose the information whatever the sensors got the information. And once if we are not we are not obtaining the informations that has sensed by our sensor, then it may affect the outputs. And location detection, this is the real challenge, and it have we must need to got the live locations, or we need the proper locations to process the Industry 4.0 and have a live internet connection, so that it can access the real-time information, and it can cooperate with the intelligent sensors. IoT, Industrial Internet of Things, again the installation of capacity on all the devices, sensors and the systems, and to appear on all desktop and mobile computers, and gather, aggregate, communicate and alert the industry to external and internal stimuli, participate in collaborative and services networks for many sectors. So if we are talking about the industrial internet of things, we need to take these points in the care. Additive manufacturing, this is one of the challenge. If you are talking about the Industry 4.2, think about the alternative that uses the best material to create a product, and think about how resistant the material that will be utilized to make the product. Think about the using waste produced during the manufacturing, and plan the best ways to get rid of the merchandise when it's no longer needed. Control production in accordance with demand and need, constantly taking the environment's effects into account. So finally, if we are talking about the Industry 4.0, the target is to achieve the definitely the target to achieve the high volume of industrial output, but at the same time we have to take in mind that we cannot affect the environment in much more. We just need the sustainable developments, and in order to sustainable development, it can be noted that the Industry 4.0 is a model that uses the foundations of other industrial revolutions that occurred previously, but with greater innovations and integration. So if we are talking about the industrial sustainable development, then just must we need the greater innovations. So the environment management 4.0 is disruptive because it can fully integrate the capabilities of the extensive set of technologies available to achieve systematic behavior that is more directed toward the effective practices of consciously sourcing inputs, correct and accurate use as needed and demanded, less waste generation and reuse, quick perception of failures and corrections, real-time contact with stakeholders, among many other possibilities. And so this was the our basically the theoretical parts, and we have another slides for the IoT for the. And I will just present it after some times. But before leaving from this sustainable developments, if you studied about the Industry 4.0, so if anybody is thinking that Industry 5.0, what should be about the 5.0, then I'm just I can just give you the suggestion. Then if we are talking about Industry 4.0, then definitely it have more and more autonomous, means the human effort is very less in Industry 4.0, but definitely the innovations are here, but at the same time we have much more exploitation of our natural resources. So definitely we cannot sustain without the natural resources, but we need to utilize as minimum as possible, so that it cannot affect our natural resources, and we can hand over the good environment system to our next generations. So if we can think about the industry 5.0, then definitely it should have the such kinds of environment where we can say that it have the minimum impact on natural resources, and it can have the minimum exploitation of the natures whatever we have, and so that we can hand over the good environment without global warming and very much unleash of the greenhouse effects. So we can hand over the good environment to our next generations if we are thinking about the industry 5.0. So definitely industry 4.2 have the much more innovations, but I am expecting from next generation people to have the better environment in next generation of industry. So this is from my side about the industry 4.0, and we have some more discussions about the IoT. So can we proceed for that?
Oh, yes, sir. Sure, sir. You proceed, sir.
Okay, thank you, ma'am.
Welcome, sir.
So if anybody have the questions related to here, we can discuss. Otherwise, we can go to the next session.
Dear participants, if you have any doubts, okay, sir. You please continue, sir.
Okay, thank you.
Anyone is asking question? Okay, sir. You continue, sir. We shall ask at the end of the session, sir.
Okay.
Okay, sir.
Okay, thank you. So actually, we have discussed about the environment and management in the industry 4.0, but the another thing is that at the same time we must need to discuss about the IoT platform, and that is really happening in our current scenario. So let's talk about the hands-on projects. And definitely here we are not going to present the hardware and all the things, but definitely we will discuss about the steps that are involved in the hands-on projects, and so that if anybody or any students wants to perform their projects related to the IoT, then they can proceed with that one. So again, the same thing, we are just trying to the Department of Instrumentation and Control Engineering and ABC College of Engineering to give these opportunities. So let's start the demo related to the IoT platforms. So what is exactly IoT? If you are talking about the Internet of Things, so if we are thinking about the Industry 4.0 and we are not talking about the IoT, then definitely it's the half of things that we have discussed. So if we are thinking the Industry 4.0, the industry IoT is automatically comes in our minds. So IoT is a system of interrelated computing devices, mechanical and digital machines, objects, animals or people that are provided with unique identifiers and ability to transfer data over a network without requiring human to human or human to computer interactions. A thing in the IoT can be a person with a heart monitor implant, a farm animal with a biochip transponder, and automobile that has built-in sensors to alert the driver when tire pressure is low, or any other natural or man-made objects that can be assigned an IP address and is able to transfer data over network. IoT is basically a sensor network of billions of smart devices that connected people, systems, and other applications to collect and share data. So why we are talking about the Internet of Things? So apart from the automations, organizations in a variety of industries are using IoT to cooperate more efficiently better understand customers to deliver enhanced customer service, improve decision making, and increase the value of the business. So if you are thinking that how it can work, so it involves the different steps. That is, Internet of Things have the sensor devices which can definitely got the data, whatever we need to process, and connectivity. We definitely need the active Wi-Fi or any kinds of internet facilities so that we can provide the live or real-time data connection. And then we just need the data processing so that it can be the cloud or it can be accessed from any data centers. So data processing is one of the key steps, and definitely it have the user interface. Then only we can complete the IoT. So these are the things that involve in this process, and we can perform the IoT. So we have some of the examples, exactly the hands-on demo project using the IoT platforms. So what are the things we need exactly? We can make it by using some kinds of microcontrollers. So it have here are some steps that involved in this designing of the demo projects on the IoT. So here is the microcontroller or single board computer that can connect it to the internet, such as Raspberry Pi or an Arduino. Second, the next step, we need the sensors or actuators to collect data or control devices in your project. For example, you might use a temperature sensor or to measure the temperature in a room, or a relay to control a light. The third step is that an IoT platforms to collect the store and analyze the data from your sensors. And some popular platforms include ThinkSpeak, AWS IoT, and the Microsoft Azure IoT. And the last step is a way to utilize the data from your sensors. This could be a simple web page or mobile app that displays the data in a real time. So, or a more advanced dashboard that allows you to interact with the data. So we will also discuss, this is the general steps that involve the IoT. So we will also discuss the examples with these microcontroller with the Raspberry Pi systems or Arduino systems. So both of them we will discuss in the next consecutive slides. So hands-on project using IoT platforms. So first, if we are talking the IoT platform using the Arduino board, so we just need these different steps. So first step, we use an Arduino board with a temperature sensor to measure the temperature of a room. With the help of the temperature sensor, first of all, it will observe the temperature, and definitely it will pass the sensing device to the Arduino devices, and use the ThinkSpeak IoT platform to collect the temperature data and store it in the cloud. Then next step, create a simple web page using HTML, CSS, and JavaScript to display the temperature data in real time. Then use a relay to control a light based on the temperature data. The next step, connect the Arduino to the internet and upload the code. Finally, access the web page from a browser to see the temperature data and control the light. So these are the steps. With the help of these steps, we can perform the hands-on project using Arduino boards. So let's talk about the examples. So here is an example. So we for the executing this demo project using the to perform the IoT project, this using the Arduino system. So we need the Arduino board of it may be Arduino UNO and a temperature sensor, maybe LM35, and a display. So we can have the LCD display like system, maybe involve the 16x2 or someone else. So these are the hardware devices we actually need to perform this demo IoT based project. So first step, connect the temperature sensor to the analog input pin of the Arduino board and the LCD display to the digital pins. Then write a sketch, that is the program, using the Arduino IDE that reads the temperature sensor value and displays it on the LCD displays. So if the hardware is not properly it cannot work. So definitely we have to run the program in the Arduino IDE, and then only it can access the data and the sensor can properly work. So the next step, upload the sketch to the Arduino board and observe the temperature using the display on the LCD. The Arduino board can also be connected to the internet via Ethernet or sealed and send the temperature data to the cloud. For these are the steps involved in this demo project based on the IoT. So this is just simple project and demonstrate the basic idea of using Arduino for IoT projects. And more complex projects can be built using different sensors, actuators, and cloud services. And also it can involve some another kinds of the devices, like it can have some more Arduino devices or more some kinds of another storage devices. So if you are thinking the projects with some another if you are thinking about the Raspberry Pi, then we can have these kinds of hands-on projects. So these kinds of projects may involve some steps like setting up the development board, such as Raspberry Pi as the IoT device, and connecting the board to a temperature sensors and relay to control a heating cooling system. And then again we need to writing the code to collect the temperature data and control the relay based on the data and user input. This is through a mobile app. So this is definitely a common steps for both of the type of the boards. And then setting up a cloud platforms such as AWS or IoT to securely transmit data between the device and the user mobiles app. And integrating the project with other smart home devices and services such as voice assistants and energy monitoring systems. And so the final product and its functionality by demonstrating how the user can control the temperature of their home remotely via the mobile app or voice commands. So this is the example that involve the Raspberry Pi. So to execute this demo, this hands-on projects demo using the IoT platform, we need the Raspberry Pi and some thermostat and the software, that is the Raspberry. So the first step involves the setup your IoT platforms. For this demo, we're using the popular platform Raspberry Pi. We can have the Raspberry Pi kit, which involves the everything what exactly we need. It actually the board involves all the things. This is definitely the popular board. And connect your Raspberry Pi to your local network. Connect the Raspberry Pi to your router using an Ethernet cable or set up a wireless connection. Then, and the next step, install the necessary software. Here we need to install the Raspbian operating system on our system, as well as any necessary libraries or programming languages. Like if we are talking about the Arduino, then we can have the C or C++ language. It may involve some another language. So build your IoT devices. For this demo, we will be building a simple temperature sensor. We can use a thermistor or a thermocouple to measure the temperature and connect it to the Raspberry Pi using a breadboard and some jumper wires. And again, write the codes properly. We need to write the codes properly so that it can run the sensors and it can process the data and give the proper output. So here we need to write the code to read the temperature from the sensor and send it to the IoT platform. We can use the Python or another programming language to do this. So deploy the code. Once our code is written, then we can deploy it to our Raspberry Pi and test it out. And where we have the temperature sensors reading, then definitely it can interface with the IoT platforms. So in order to enhance it, we can add some more functionality to our IoT devices, like sending notifications when the temperature exceeds a certain level, maybe 15 degrees Celsius or 30 degrees Celsius, so whatever we can choose. So we can enhance definitely. And please keep in mind that this is just a basic example. If we want to customize, then definitely we can advance it by using some more sensors, and we can have some more advanced devices, and definitely we can have. It's also depend on the programming and all the things. So we can enhance it. So there are various applications that is involved in IoT applications. It may involve some smart city, smart car, wearables, smart applications like it can be used in the buildings, smart TV. So various examples can be possible, and we just will discuss some of the popular applications that involve by using IoT based. So here is some examples. The smart world for the future using IoT, and it can involve some kinds of sensors used in the building and in traffic system and in the any industrial system, and wherever we are exactly, we can use it our home also. And this IoT system definitely improves our standard, and it can have much more facilities. So we can save our time, we can save our environment, and we can also enhance our industrial performances by using this IoT. So here is some examples. So if you are talking of helmet, consumption sensors, medical alert watch, a smart fitness clothing, and smart running shoes, one button products purchases, garden sensors, smart television. So these are the examples which is related to the IoT. Kinsa thermometer, this is one of the examples of IoT, and it can monitor our temperature, and automatically it will give some of the required output like temperature or whatever is there any fever or cough you have, it may call your doctor. So this is the example. And connected car story. The connected car is equipped with internet connection and software that allow people to stream music and look up movie times, be alerted of traffic and weather conditions, and even power driving assistance services such as self-parking. So fully based on IoT applications. A smart farming, use of IoT to improve agriculture. Definitely IoT can improve the way of the farming, because it can reduce the human effort, and it have the IoT-based smart farming system is built for monitoring the crop field with the help of sensors. And sensor may involve the light sensor or humidity sensor or temperature soil moisture sensors. So whatever the outputs exactly we want, we can correspondingly use the related sensors. And automating the irrigation systems. So the farmers can monitor the field conditions from anywhere. This is highly efficient compared to the traditional or conventional approach. In terms of environmental issue, IoT-based smart farming provides great benefits, including better and efficient water uses and optimization of input and treatments. Therefore, smart farming based on IoT technologies enables growers and farmers to reduce the waste and enhance the profitability. Ultimately, our target is to enhance the profit that can be done by using this de-waste. So some of the applications in this farming area, it can be the precision farming, agriculture, drones, livestock monitoring, smart greenhouses. So these are the things which can evolve. And if we are talking about the agricultural drone, this is the key technology that is evolving nowadays, and we have the different applications related to this agriculture drone. And definitely my company is also working on this agriculture drones to give the some IoT based output so that it can enhance the performances of the agriculture based farming, and we can give the more profit to farmers. So this is the evolving technology, and it can be used based on the IoT. So there are some more applications like industrial IoT. It can be known as IIoT. So it focuses on the use of the cyber physical systems to monitor the physical factory processes and make data-based automated decisions. While the physical systems are made the intelligent using IoT, the real-time communication and cooperation both with each other and with humans is established via the wireless wave. So IIoT brings in the concept of a connected factory leads to a smart factory. So exactly, it have much more benefits, so we cannot combine it in one slide, but here is some highlights. So IoT offers a number of benefits to organizations, enabling them to monitor their overall business processes, improve the customer experience, save time and money, and enhance employee productivity, integrate the adapt business models, make better business decisions, and generate more revenue. So these are the benefits by using the IoT, that is Internet of Things. So thank you. So these are the things which is from my side.
Thank you, sir. It is extraordinary, that is that hands-on project demo using IoT platform with Raspberry Pi. Thank you very much, sir. Shall we ask the participants if they have any queries, sir?
Yes, yeah.
Okay. Dear participants, if you have any queries, you may clarify now.
Hello. Hi, Prakash here. Okay. So I have the query on how we can push the data to the cloud using the Raspberry Pi. So we have the Python library, the standard libraries, right? So we don't need any Microsoft Azure services or AWS services. We no need. So directly we have the inbuilt Raspberry Pi libraries to push the data, right? How
Yes,
it
yes.
will work? Okay. So there is no licensing or I don't want any subscription. It's a freeware or how we can proceed with this?
Yeah, if we are staying in India, then it's free for different bands. But if we are talking about the abroad, then I cannot say. But here, in India, it's a depend on the frequency band what we using. So mostly things for the study purpose. If you are talking about study purpose or some of the things, then it is free to access to all of us.
Okay. So basically, it's depend on the geographical
Yes,
service.
yes,
Yes.
yes.
Okay. Okay. Got it, sir. Thanks for that.
Thank you.
Any other participants? Do you have any doubts? Okay, sir. Really, the session is very useful. 3D printing the future, we came to know about the things. And I wondered about your dedication from the starting itself. You have so much of commitment in preparing this content for presentation, and you are attending all the sessions from the inaugural session, so it's very amazing, sir. I'm proud to have you as the eminent speaker of this session, and really it's very nice to have you for this FTP, and your session is very informative and very useful, and all the things you demonstrated are very nice, sir. So I thank you very much for being with us and sparing much of your time for this presentation. I thank you very much. Thank you so much, sir. Thank you, sir.
Thank you, ma'am, and thank you all the members. And I'm just leaving with a message that if you are thinking about the next level of industry or revolution, then must think about the environmental system, because we want the environment as actually we are exploiting the much more natural resources, so we must need the definitely we need the development, but with the not cost of the a bad environment and the exploited environment. So we need the sustainable environment. Then only we can sustain for a longer duration. Means human can sustain on the earth for a longer duration. Otherwise, our next generation will suffer, and we will actually not sustain to longer duration. So definitely, we have to see the environment.
Thank you, sir. Thank you so much. Dear participants, the feedback and assessment link is posted in the chat box. It will be kept open until 8 p.m. today, and kindly join at 9:45 a.m. tomorrow for the third day session. Thank you, participants. Thank you, sir. Thank you, Prakash, for being with us. Thank you all. Thank you. Thank you.